Welcome back to Built to Ship, the podcast where we go behind the scenes with founders and product leaders shipping real AI products into the world. I'm your host, Tyler Postal from Voker. Today, I'm excited to be joined by Hrishi, co-founder, founder, and CEO of Southbridge, a company building the agentic data layer for AI systems, helping agents reliably access, transform, and reason over complex data. Hrishi, it's great to have you.
Good to be here.
Yeah, well, I'm excited to get into it. Why don't we start with the founding story? What were you doing before Southbridge, and how did you get the idea?
Oh man, the founding story before Southbridge, depending on how far back you want to go, is just every problem I've ever struggled with has on some level been a data problem. And I was writing about it like 7 years ago, going maybe we're never going to solve this because you need a general intelligence to be able to figure out what's an outlier and what's not. Right? Bit of background about me: I spent a few years in insurtech, and then right before Southbridge, I was working in sort of shipping, and it was all data problems. We were trying to solve multidimensional optimization for vessels, something that might have been definitely useful these days. And it's all just we've been holding on to information for 15 years, right? Like we record everything, we store everything, companies and people alike, but most of it's recorded with no real idea of how to make it useful. And that life cycle only really completes when it gets used for decision support, right? Almost all data honestly only is ever really useful once it's used to support a decision. That is the hardest part. Like in my last company, we had some of the smartest people I know who spent most of their time cleaning and modifying and ingesting data. So LLMs show up, and like my old background is reasonably ML. And I look at these things initially for NLP, and then I just couldn't shake the idea that we possibly could, in an unsupervised fashion, solve a lot of the stuff that we kind of have to deal with data. At the time, there was a period when it was like, oh, maybe context windows are going to get massive, and maybe this isn't. But even then, we make more information consistently than you could ever fit into a context window. So that's how this whole thing got started. All of this got started because I went, it likely might be possible now to end-to-end in an unsupervised way solve ingest, solve transformation, right?
Love that. Yeah, no, definitely. And I think a point that I appreciate in everything you're saying is like, okay, nowadays people finally understand, okay, you need to collect data. Like it's important, even if you don't know today how you're going to use that for analysis 2 years down the line, 3 years, 5 years. Is it train a model? Is it do analysis on how this pricing change impacted business performance? People understand they need to collect it now, but they don't still all understand like how to refine it. And so you hear, I used to lead data teams before founding Voker, and like you'd hear executives say, we need to collect data, like data is oil, all those things. But then like if you don't refine it, if you don't store it in the right way that it's usable, if you don't give other people access to it, whether it's the data science team or business folks in like a way that they can utilize it, then it's really still useless. And now you just have a big, database bill. So I love that. I want to dig into that more. Maybe tell us a little bit about Southbridge. What do you guys do? Who are your customers? Set the stage for, who's using the products once we get into all the agentic and AI features.
Cool. Southbridge, the name I think is like a bit of a nerd throwback to Southbridge used to be a chip on your motherboard, right? That was designed to connect your central unit, when we called it a CPU, to the outside world. So its job was to take all the information from all of your different buses and bring it into the CPU. So that's what used to be a Southbridge. You used to have a Southbridge and a Northbridge. Southbridge was for external stuff, and a Northbridge was for internal stuff. I think eventually got pulled into the CPU. So that was always the idea. And like since we got started, that's all we've tried to do, right? And as models have gotten better, we've kind of intersected a little bit with like, what do we need to build? You only need to build what you need to. The problem with data is always that like it's crazy diverse. Like the data sets are diverse, almost as diverse as the people using them. The stacks are diverse, almost as diverse as like the companies that do different things. So we started out focused entirely on ingest, and then sort of grew from there into like different kinds of agentic work that can be done with information, right? So some of our customers like use some of the tooling that we have for things like figuring out liquidity profiles in sort of financial markets, or mining health data across sort of different countries to figure out what correlates in terms of health outcomes and medical procedures. So mostly so far, I would say the broad class of use cases have been either data onboarding and cataloging, or modification and sort of report generation, right? Our goal has always been to figure out how to do each layer reliably before moving on to the next one. And that word is like hard. It's hard to deliver reliability.
No, but it's an important word, especially in the age of agents and AI. Obviously, everyone talks about how capable they are, but also like, can you trust them? What harness or framework or, other tools do you need around to make it reliable? When it comes to this ingestion piece you're talking about, help me understand like how deep into ingestion do you go? And I think I come from like, e-commerce and digital marketing space. So I think of tools like Fivetran or others that are kind of like, oh, we already have integrations with Facebook ads, Meta, etc. Do you guys go that deep that you have like, ingestion points? Are you focused on a specific industry, or is it super broad? Like what types of data you ingest or enable ingesting?
Okay, so I think before we started, I said it's a couple of people in a shed. And so we're still kind of dumb enough to be broad and dumb enough to be horizontal. So we are. And as far as the ingestion part goes, I think we lightly touched on HankWeave. Part of how we arrived at HankWeave was trying to solve that integration sort of connector problem. Because if you're a startup and you're a small company, you still need reliable connectors to a large number of things, but you do not have the people, right? And so HankWeave initially started as what we call, sealed agentic flows, which is, can you put, and nowadays I think there's a name like a software factory, which is, can we take the interfaces to our systems with a spec and a test suite, and can we just completely automate like a just-in-time connector to whatever needs to be built? That's where all of that started. So today I'd say we have effectively what we call like agentic shims to different things. So if you wanted an agentic shim to sort of Pi, all you do is you pull the right Hank in and you just say, go build me a connector to Pi, the latest version of Pi, the latest version of Fivetran. But it's also interesting that you mentioned Fivetran, because you kind of decide which way to go first. And one of the early opinionated bets that we picked was to go after small data, right? And small data is still huge for models and agents, but this is like what the DuckDB guys talk about, which is, I think, SSDs, CPUs, everything's gotten faster. So I think you can do a lot in like the sub-terabyte range. So most of the tooling that we've connected to has been, how do you ensure reliability on thousands of tool calls in the sort of sub-terabyte range of tools.
Very interesting.
And proceed from there, right? Once you can establish good enough reliability there, then you sort of build up.
Very cool. So when you say just-in-time connectors, it's not like you've built an integration, specific to every single sort of platform that exists in the world. It sounds like these shims, are they different? Like, oh, if it's web scraping data, you use a different type of shim, and if it's a different type of data, use a different one, but it's not specific to a specific vendor or platform. Is that kind of what you're getting at, or am I understanding that correctly?
It's not specific to vendor or platform at all, right? I mean, something that we ran into, and I think almost anyone data is running into, right, is that it's not just products, but the products themselves have such a wide surface area, and customers only use specific things, that the same product, whether that's Fivetran or like something specifically into Azure, can look like a different product depending on the customer, right? Because it has to go through their VPN or their system with the specifics of their life, which is, we had a data person come in, we had a data team 4 months ago that operated this way and not this way, and they use this flavor of this thing. So,
or they use this column that's named this thing for a different field that you didn't expect. So you can't, I totally,
exactly.
Love that.
So we had to make that call early on, which is, I think most data companies, all of the ones that I know that I spoke to, all had to make that call early on, which is, do you go after like next gen, current gen things and just go, we support the latest of everything for new people? Or do you go after do you help support the rest of everybody else's data, right? Guy that's on, I was that guy, like guy that's on SQL Server, right? SQL Server 2003, right?
Yeah.
And, so in a lot of ways, that's what we were going for. So these just-in-time connectors almost don't care, because they're a perfectly encoded spec of what we want to see on the other side.
I like this approach, because I personally think that AI, we're an AI company. AI is really impressive. There's a lot you can do with LLMs and agents, but they're not magic. They don't often live up to the crazy claims that people make. And, everyone telling you, oh, just write a better prompt. Like there's so much more that goes into building a good agent. And you guys are focusing on one of those important things, which is, providing data to tooling, et cetera. So maybe tell the audience, like, what are some pitfalls or what are some of the benefits you get from either investing or not investing in these parts of an agent instead of just having an LLM call with a single prompt, and maybe one or two tools. What are they missing, from not having more infrastructure around their simple agent system?
That's a really good question, right? I think, in a lot of ways, the stuff that we focused on, I think, is going to become more and more important, even on like an individual company level, even if we're not specifically the people touching it, which is what I would class as sort of first mile data stuff, right? And even pre-AI, the first mile of what you do with your data before it becomes useful has generally been left to user. And even today, I think it's in a lot of ways the same thing, right? You might have a large number of coding agents active inside of your system. You might have people using things differently. But that first mile of how data gets into that system usually is, exercise left to the reader, right?
Yeah.
Yeah.
No, go for it, please.
Oh, no. So my consistent recommendation is like AI creates so much data and has such a dilutive effect and sort of randomizing effect on what you have already. And like you usually want to start having that hygiene very early.
Mm-hmm.
Right.
And so like when you're actually ingesting the data, you're making sure that you're labeling it right. You're only collecting the things you need, et cetera. And then that helps you when you're feeding it to, the context window, et cetera, right? Is that kind of what you're getting at?
Yeah.
Okay, awesome. What's maybe a use case, like a tangible example of like how someone would use Hank Weave, and what's the difference between using it or not, for the performance of that agent?
Got it. The disclaimer I want to give at the beginning is that Hank Weave almost was never intended to be used directly, right? Like we started bottom up when it comes to building the stack, right? So Hank Weave was built as bottom of the stack software, which is highly configurable, highly reliable, like used in a large number of things, but almost not necessarily designed as the end user product, even for a dev, right? And it shows a lot of that, right? But the primary intent for us having Hank Weave is to have two things, and I'll give you the broad, and then I'll go into the specifics. Is one, to have a surface to accumulate fixes, right? Like when you are doing operations with data, when you honestly doing really anything agentically, you want some surface that you can improve, right? And to a certain extent, that's why people like skills, because skills in some cases are that surface if you manage them well and there's like good hygiene there. But even then, you can think of Hank Weave as largely just a sequence of skills just executing in their own sandbox. So we, at this point, use it for everything from like planning out work that goes into Hank Weave, from migrating information across sort of different cloud platforms on our side, from shipping, solutions that we've built for partners over to their side. So it solves a lot of those problems for us, right? Mostly it solves those problems just by giving us some sort of scripting service to fix and modify, right? And the thing that we prioritize with Hank Weave quite a bit, because we had to, is just the debugging path. So the problem with Greenfield is like, I think most of us don't get to the debugging path, but anyone who gets there, I think appreciates that, like, to have a clean path to solve problems makes things a lot easier.
Definitely. And I imagine you have a lot of, challenging problems because it's, you guys mentioned on your website that you build complex data agents for long task horizons with tons of tools. What are some of the challenges that come, not a lot of people, people have tried MVPs and things like that for a long running agent, but the industry is still really early. There's a lot of companies that like have promised they're going to build 200 agents into their product. And they still haven't. They've maybe launched one. And so not a lot of people have actually gotten to this point where they've built complex agents with, memory and good data pipelines and hundreds of tool calls. What are the biggest challenges that you've seen when you're actually like not just building them, but operating them in production? Yeah.
So there's two big ones, right? And again, like most of what I'm going to say is kind of hold across a large number of generations, because if you look at Hankweave and sort of the history there too, like we were doing this stuff back in June last year, right? So we had sort of like 10, 11-hour agents and had to solve all of those problems well before like Opus made our lives just that tad bit easier, right? Opus 4.6. So but the problems back then are still the problems now, which one of them is models are wonderful slop generators if you let them, right?
Yeah.
So a good chunk of the work that happens when you go into long horizon is just managing the volume of data that comes in, and then in some ways managing that agent thread from going off in the wrong direction and then just generating a bunch of slop, right? That is incredibly difficult. And then we have the appropriate type of mental illness to have big data, which is tends to be bottom of the stack work, right? Meaning any hallucinations or issues in that stack, at that layer, sort of compound up, right? Because you are usually pretty far away from the final thing that happens, right? Like the information that gets processed by a Hank or that gets processed by a long horizon agent goes into a database where it might sit there as a grenade waiting to go off for 5 years, right? Until the day that it gets read back out and a decision gets made on that data, at which point the agent that did that job and the human that did that job is long gone, right? So you kind of have to make things as reliable as possible. So most of our work goes into that.
Very cool. On the note of like these grenades that you don't know exist in your, in your agent outputs, what do you think about the different methods that exist today to monitor, measure, evaluate agents in production? What's your opinion on like evals and LLMs as a judge? What tooling do you guys use, beyond Hank to make agents reliable, to keep track of them when you have hundreds of agents with thousands of tool calls in production?
So I think a good chunk of the tooling, I think, that existed around this stuff is now out of date, right? Because we had that sort of line between when agentic harnesses became useful and that pre-period where we were all just relying on like sort of single LLM calls. So a lot of the software and sort of tooling that, including us, but also just stuff that we bought and sort of that existed pre that transition point, just doesn't work anymore, right? So there's a lot of backbones, there's a lot of eval methods that just don't work anymore at the scale of, it's the same comparison between direct, feedbackward training versus RL, meaning the actual action that you're talking about, which once used to be a single LLM call, might now be 200. And 5% of those could be errors, and you might still have a successful output, right?
Totally.
So most of our work has been in trying to manage and sort of maintain that, like catch deviations at runtime, right, at test time. So the pattern that worked really, really well for us is what we call sentinels, which I still don't see around. So either we're wrong or we'll see. So Hankweave supports the original name was Chroniclers. I think Sentinels was like someone else. We rename stuff a lot. We shouldn't. Sentinels is effectively things that can trigger on the core agent loop, because we found that it was way easier for us to catch and fix problems in the agent loop if we had sort of customizable triggers on things that happen in the agent loop, and then like an LLM sort of as a judge, but more write to files that then get read back into the agent loop. It was trying to figure out the data flow there that was really interesting, right? So an example might be, one of the things we recently ran into was agents sort of building schemas, and there's known failure modes with agents building schemas, right? That we see with specific things. The traditional current method of solving that would either be to like, do this in like triple caps with emojis in the system prompt, all the way to why don't we catch it at the end? Why don't we catch it, and fix it after the thing's done? The Sentinel method that works really well to solve that would be like a simple sort of trigger written, that might just look for file writes with Zod in the with the regex and go, okay, trigger on that and look for these problems and write those back into the agent loop as, these are some of the problems that happen. I'm starting to see similar patterns implemented with hooks in Cloud Code, but hooks were never really designed for that. And so you run into teething issues, but it's the same thing.
Very interesting. And when you design these sentinels, did you think ahead of time as you're architecting the system, like, oh, this is going to be a place that we obviously need a sentinel? Or is it something that you figure out as you go along? You're like, oh, this thing's failing on Zod files. Let's add something in to watch it.
It's honestly neither. Sentinels were honestly not even built for that purpose. They ended up being really useful. Sentinels were built to cut the amount of information that happens in sort of a long horizon agentic run to whoever's monitoring that run, initially for humans, and then for the agent that sits on top, right? Because you just have so much happening that you kind of just want a bird's eye view of whatever's happening now, right? So sentinels were initially built for translation because some of our partners ideally they like to not have the output in English, and they got used again for orchestrator agents because it's really useful to cut that down, because there's an orchestrator agent sitting on top of these things who also has a context window of like a mil at most, or 200K of useful context. So that compressing that information down is also really, really important before that thing blows context. So chroniclers got built for that. And then they became sentinels when we were like, oh, they're actually really, really helpful to solve common issues and problems.
It's so cool how much like we're just figuring things out as we go, and like, oh, you designed this for this thing, and now we realize it's useful here. And so it's definitely an exciting time.
Right. Like, honestly, none of us have any idea what we're doing, right? But especially with no idea what we're doing.
As long as you're doing something and you have some method to how you're like measuring if it's working or not, and then you're iterating, like that's the state we're in as an industry. Maybe one more technical question before we wrap up. Since you guys are, focused so much on the data side, I don't know if this is in your wheelhouse or not, but I'm curious what you think about like using LLMs for text to SQL, or this general space of, we're an agent analytics product. Eventually we'll have an analyst that will let you do, insights on your own data. We're figuring out how we want to design that, but there's tons of AI analyst products that are out there, a little different. Do you guys have you done any work in like the text to SQL space? Do you have suggestions on how to do like data analysis with LLMs? Is it have them write SQL, or is it like have them have tool calls to APIs that return specific like aggregate metrics? And then, what have you seen as an architecture that works there, or is that kind of not your main focus?
No, that's a wonderful question, and it depends on the scale of data, right? This is something that we have run a crazy amount of internal tests on just a good while ago. One of my projects right before Southbridge was called Wishful Search, which was like GPT 3.5 days, which is around sort of text to SQL and sort of SQL execution inside sandboxes to try and do sort of real-time data. I think I might be wrong about this, but I still go that SQL is just not an expressive enough language to do work, right? Partly because it's the declarative nature of it means it's expensive to execute, especially as like the thing that you're accessing gets bigger. Agents generally don't like doing that, and in most cases, you still get all sorts of like weird problems. Like a complex query is often far better and more readably expressed in Python or TypeScript than in SQL, right? So when we were doing SQL way back, we would get into queries where I would stare at it and I would go, if I can't understand this query, I don't know how I expect GPT-4 at the time to understand it. Today, I still feel like it's a little mean to try and get Opus to understand that query. Much less write it, right? When that's what's needed. I think SQL, as much as I love SQL, worked in SQL a lot, like SQL with its CTEs is just not an expressive language to do it. It's the same problem as like JSON versus YAML, right? It's been a pretty useful rule of thumb that if you can look at it and it's readable to a human, I think an LLM will find it far easier to execute in.
That's a great point. And then when it comes to this, like, approach it with Python or TypeScript instead, is it still just pretty much like let it write all of the quote unquote queries, or do you give it endpoints that are specific to certain metrics? Like, oh, here's already an aggregation of customers by week. You can call that tool, or is it just like carte blanche? Here's access to the full, data structure, and just use Python to write a way to make something intelligible.
Okay, so I'll say something a third door, right? Like something in the middle, which is LLMs are wonderful sort of edit machines is what I've seen, right? Agents are. If you can give them, like, say, for example, even just very simply, this is why skills have been some level of successful, right? Here's a folder of high quality scripts that don't do the thing you're asking for, but they do other things well, is this huge performance bump as far as LLMs are concerned. The other two methods of doing it, right? One, which is like, hey, here's an API that does the thing that you want it to do. I think oftentimes runs into problems I've seen happen with MCPs and sort of APIs, which is the second largest class of problems I've seen with our partners and just large data work is when the LLM presumes something about some sort of abstraction layer that just isn't true, right?
Yeah.
Like it reads data out of a user's API and it goes, oh, this has to be monotonically increasing. It's not told it that, right? Some sort of mismatch, like even the Claude Code harness, for example, we ran into some problems with images where neither the LLM nor we knew that the harness was compressing images down to like tiny sizes. So for a long while, the human and the LLM are both confused because neither of them know what's happening, right? So I always say beware abstractions. That's getting the LLM to write the code in real time. You're lucky when it works, but there's no way to fix things. If you see problems, there's no way to fix it. Right? So it's usually better to have a working piece of code that almost like encapsulates what you want, maybe not doing the thing you want it to do, and then have the LLM modify it to do what it does.
Great. I love it. Hybrid approach there is probably the best. Okay. I could keep asking you questions all day, but I know it's late for you over there. We've got to close out. I want to put your website up on the screen, southbridge.ai. Tell the audience, how do they follow along? Who should check out Southbridge and Hank Weave? Any socials they should follow you on.
So I'm on Twitter, like Minu, my co-founder, is also on Twitter. And as far as Southbridge goes, if you're someone that's dealing with sort of like large amounts of information coming in, that might be because you're trying to integrate new companies coming into the stack, or if you're sort of an AI company that's got to integrate user data in sort of large amounts, and you're far enough along using agents and sort of AIs to do it, that maintainability and having a clean debugging path is starting to resonate. I think you're right in our wheelbase, right?
Amazing. And how should they check out Hank Weave? Is it something they can just download and try themselves? Do they need to book a demo, anything like that?
So Hank Weave is completely open source because I think more testing and more users, thankfully we've gotten a lot of it, is great for bottom of the stack infrastructure, because the more reliable that is and the more bugs are ironed out, the better for all of us. Is completely open source, and you're welcome to check it out. The documentation, we have almost all of our Hanks are open source as well. So we have everything from Hanks to build comics to Hanks that build shims to popular coding agents. So we actually internally are able to switch between coding agents to do different things because we have shims built by those Hanks. But if you reach out, we can also share some of the things that we don't think are mature enough to open source, but are cool nonetheless, like the orchestration layer that sits on top, or the systems that we have that sort of build Hanks in real time and sort of execute them.
Amazing. Okay, well, this has been super insightful. Thank you so much for your time, Hrishi. This has been a great episode. And to everyone listening, thanks for tuning in. If you're building something, go ship it, and we'll see you next time. Bye now.